Whether you're sipping your morning coffee or catching up on the drive, we've got the industry insights that matter. I'm Steve, here with Claire from the Auto Agentic team, and today we're diving deep into one of the most complex challenges facing our industry, the environmental paradox at the heart of EV battery supply chains.
Thanks, Steve. You know, when we talk about electric vehicles being green, there's this fascinating contradiction that's often overlooked. The very batteries that power these clean vehicles come with their own substantial environmental footprint, from mining to manufacturing to end-of-life management.
Exactly. And the numbers are staggering. The International Energy Agency just released their Global EV Outlook 2024, showing that global battery demand reached 850 gigawatt hours in 2023. That's a more than 40% increase from 2022. But here's what really caught my attention. They're projecting that battery demand will grow almost 7 times by 2035 under their stated policy scenario. That's not just growth, that's an explosion.
Almost 7 times larger. That's incredible. And what's driving this isn't just passenger cars, right? We're seeing electrification across commercial vehicles, two-wheelers, even stationary storage applications. But with that growth comes this fundamental question: can we scale battery production sustainably?
That's the crux of what we're calling the green paradox. Let me share something that really illustrates this challenge. According to recent research, battery production currently accounts for nearly 2/3 of an EV's total greenhouse gas emissions during manufacturing. Think about that. The component that makes the vehicle clean is responsible for most of its upfront carbon footprint.
It's counterintuitive, isn't it? But I think it's important to put this in perspective. The IEA's lifecycle analysis shows that even with this upfront cost, a medium-sized battery electric car produces half the emissions of an equivalent internal combustion engine car over its lifetime. So we're still net positive, but there's clearly room for improvement in that manufacturing phase.
Absolutely. And when we dig into where those manufacturing emissions come from, it gets really interesting. The extraction and processing of critical minerals, lithium, cobalt, nickel, graphite, that's where the environmental impact is most concentrated. Let's talk about lithium first, because the numbers here are pretty shocking.
Lithium extraction is particularly water-intensive. In places like Chile's Salar de Atacama, an estimated 500,000 gallons of water are consumed per ton of lithium extracted using evaporative technology, with 95% of that water permanently lost to evaporation. In a region that's already arid, this is causing groundwater depletion of up to 1 meter per year.
And it's not just water. The carbon footprint varies dramatically depending on extraction method. Hard rock mining produces over 5 times more carbon emissions per ton of lithium than brine extraction. So the source of your lithium matters enormously for the overall environmental impact of your battery.
That's where some of the innovation is happening, though. Direct lithium extraction technologies are emerging that could significantly reduce water use and return most of the water back to aquifers. It's still early stage, but it shows the industry is aware of these challenges and actively working on solutions.
Now, Cobalt presents a different set of challenges, not just environmental, but ethical ones too. The Democratic Republic of Congo accounts for over 70% of global cobalt production, and that's been associated with serious labor and human rights concerns. But here's where recycling becomes crucial, and the numbers on cobalt recycling are actually quite promising.
The European Union's new battery regulation is really driving change here. They're mandating recovery rates of 90% for cobalt by 2027 and 95% by 2031. And the projections show that recycled cobalt could meet up to 19% of European demand by 2030, growing to 40% by 2035.
Those recycling rates are impressive, but they highlight another challenge: timing. Most EV batteries have a lifespan of 8 to 15 years. So the volume of end-of-life batteries available for recycling is still relatively small. Right now, most recycled material is coming from manufacturing scrap rather than actual end-of-life vehicle batteries.
Exactly, and that creates an interesting market dynamic. Research from ABI shows that by 2030, planned recycling capacity in the US will actually exceed the volume of available waste batteries. We might have too much recycling capacity too soon, which could lead to uneconomic utilization rates or delays in recycling projects.
That's a fascinating problem to have, too much recycling capacity, but it also shows the industry is preparing for that wave of end-of-life batteries that's coming in the 2030s and beyond. Speaking of preparation, Let's talk about the supply chain bottlenecks that are already emerging.
The supply constraints are real. Mike Dean from Bloomberg Intelligence has been tracking this closely, and he's warning that lithium battery supply could bottleneck from 2025 as EV demand outstrips available battery production capacity. And it's not just capacity, it's the cost of raw materials too.
The price volatility has been incredible. Lithium prices have been on a roller coaster, and that directly impacts battery costs and, ultimately, EV affordability. But there's also a geopolitical dimension here that's often overlooked.
China's dominance in the midstream processing of battery materials is a strategic concern for both the US and Europe. Wood Mackenzie notes that China's capacity share in refining and processing presents significant supply chain risks. That's why we're seeing massive investments in domestic battery production and mineral processing capabilities.
The Inflation Reduction Act in the US and similar policies in Europe are specifically designed to build domestic supply chains. But there's a question of timing. Can all these new facilities be built fast enough to meet the projected demand growth?
That's the trillion-dollar question. The IEA is projecting potential deficits of 40% for lithium and 30% for copper by 2035, even if all current mining projects proceed as planned. That suggests we need even more investment in extraction and processing capacity.
But here's where the circular economy concept becomes really important. If we can scale recycling effectively, it could dramatically reduce demand for virgin materials. The IEA estimates that efficient recycling could reduce lithium and nickel demand by 25% and cobalt demand by 40% by 2050.
The recycling technologies are advancing rapidly too. We're seeing three main approaches: hydrometallurgical recycling, which uses liquid solutions and can achieve 90 to 99% recovery rates for key metals; pyrometallurgical or smelting processes, which are energy intensive but well established; and direct recycling, which maintains the molecular structure of cathodes and could be the most economically viable long term.
You're listening to Auto Intelligence, brought to you by AutoAgentic,
the platform transforming automotive retail with intelligent, human-centered AI. Just as we're discussing the complexity of battery supply chains, AutoAgentic helps dealerships navigate the complexity of EV sales and service with over 90 specialized AI agents. These agents understand the nuances of electric vehicle retail, from lead nurturing to inventory optimization, helping dealers thrive in this rapidly evolving market.
Now back to our discussion of the green paradox. One aspect that doesn't get enough attention is the concept of second life for EV batteries. Not every battery goes straight to recycling when it's no longer suitable for automotive use.
That's right. Many batteries retain 60 to 80% of their capacity when they're retired from vehicles, making them perfect for stationary energy storage applications. The International Council on Clean Transportation estimates that reusing 50% of end-of-life vehicle batteries for energy storage could offer a capacity of 96 gigawatt hours in 2030, growing to 12,000 gigawatt hours by 2050.
Those numbers are massive. 12,000 gigawatt hours. That's enough to power significant portions of the grid during peak demand periods. And it extends the useful life of these batteries before they eventually need to be recycled.
It also creates new business models for automakers and energy companies. We're already seeing partnerships between car manufacturers and utility companies to develop these second life applications. It's another way to extract maximum value from the materials and energy that went into producing these batteries.
Let's talk about some of the technological innovations that are addressing these sustainability challenges. Solid-state batteries are getting a lot of attention. What's the potential there?
Solid-state technology is promising because it could significantly improve energy density while potentially reducing reliance on some of the most problematic materials. TDK recently announced a breakthrough achieving energy density of 1,000 watt-hours per litre. That's 100 times greater than their existing batteries. Though that's for small devices initially, the technology could eventually scale to automotive applications.
And then there's dry coating technology, which Tesla and others are exploring. This eliminates solvent-based processes and energy-intensive drying, potentially reducing carbon dioxide emissions by up to 40% and manufacturing costs by 18%. Those are significant improvements.
The manufacturing innovations are just as important as the chemistry innovations. Companies like Adionics are working on three-dimensional current collectors that reduce inactive material usage and optimize active material loading. Every efficiency gain in manufacturing translates to lower environmental impact and cost.
But even with all these technological advances, there are still significant challenges ahead. The regulatory landscape is complex and evolving rapidly. How do you see policy shaping this industry?
The EU's battery regulation is really setting the global standard. It mandates specific recycling targets, requires transparency in sourcing, and sets durability standards. But interestingly, some research suggests the focus on recycling might inadvertently suppress the market for battery repurposing. There's a need for balanced support for both recycling and second life applications.
That's a great point about unintended consequences. Policymakers are trying to incentivize the right behaviors, but the market dynamics are so complex that regulations can sometimes have unexpected effects.
Exactly. And then there's the global nature of these supply chains. You might have lithium mined in Australia, processed in China, assembled into batteries in Europe, and installed in vehicles sold in North America. Coordinating sustainability standards across all those jurisdictions is incredibly challenging.
The social dimension is equally complex. We've talked about the environmental impacts, but there are real human costs too. Indigenous communities in lithium-rich regions are seeing their traditional ways of life disrupted by mining operations. Water depletion affects local agriculture and herding communities.
And that's where corporate social responsibility becomes crucial. Some companies are working directly with local communities to ensure fair compensation and environmental protection. But it requires genuine commitment and long-term thinking, not just compliance with minimum standards.
Looking ahead, what do you see as the most promising developments for addressing these sustainability challenges?
I think we're going to see a convergence of several trends. First, continued innovation in battery chemistry that reduces reliance on the most problematic materials. Second, massive scaling of recycling infrastructure as the volume of end-of-life batteries grows. And third, more localized supply chains that reduce transportation emissions and geopolitical risks.
The localization trend is particularly interesting from an automotive industry perspective. We're seeing automakers invest in domestic battery production, not just for supply security, but also to reduce the carbon footprint of transportation.
And there's a competitive advantage there too. As consumers become more environmentally conscious, the ability to demonstrate a truly sustainable supply chain could become a significant differentiator. We might see carbon footprint become as important as miles per gallon in vehicle marketing.
The economic opportunities are substantial too. The global EV battery recycling market is projected to grow from $540 million in 2024 to over $23 billion by 2035. That's a compound annual growth rate of over 40%.
Those numbers reflect the scale of the challenge and the opportunity. We're talking about building entirely new industries around battery recycling and repurposing. That means jobs, technological innovation, and economic growth in regions that invest early in these capabilities.
But it also means we need to train workers, develop new skills, and create the infrastructure to support these industries. It's not just about building recycling plants, it's about creating entire ecosystems around circular economy principles.
And that's where collaboration becomes essential. No single company or country can solve these challenges alone. We need partnerships between automakers, mining companies, recyclers, technology developers, and governments. The complexity requires coordinated action across the entire value chain.
Speaking of collaboration, what role do you see consumers playing in this transition?
Consumer awareness is growing, and that's driving demand for more sustainable products. But consumers also need to be part of the solution. Properly disposing of batteries, supporting companies with strong sustainability practices, and understanding that the upfront environmental cost of EVs pays dividends over the vehicle's lifetime.
Education is key there. Many consumers still don't understand the lifecycle benefits of EVs, or they focus only on the upfront manufacturing impact without considering the operational benefits.
Exactly, and as the technology improves and recycling scales up, that upfront impact will continue to decrease. We're already seeing battery production becoming cleaner as manufacturing moves to regions with cleaner electricity grids and as processes become more efficient.
Let's wrap up with some key takeaways. What should our listeners in the automotive industry be thinking about as they navigate this green paradox?
First, the environmental challenges are real, but they're not insurmountable. The industry is actively working on solutions, and we're seeing genuine progress in recycling, sustainable mining practices, and cleaner manufacturing processes.
Second, the scale of the transition is unprecedented. We're talking about building entirely new supply chains and industries in just over a decade. That requires unprecedented investment, innovation, and collaboration.
And third, This is ultimately about long-term thinking. The upfront environmental costs of battery production are significant, but they're temporary. As we scale recycling and improve manufacturing processes, the environmental benefits of electrification will become even more pronounced.
The green paradox isn't a reason to slow down electrification. It's a call to accelerate the development of sustainable solutions. The automotive industry has always been about innovation and problem solving, and this is perhaps our greatest challenge yet.
But it's also our greatest opportunity. The companies and countries that figure out how to build truly sustainable EV supply chains will have a massive competitive advantage in the decades ahead.
Well, this has been a fascinating deep dive into one of the most complex challenges facing our industry. The path to sustainable mobility isn't simple, but the destination, cleaner air, reduced emissions, and a more resilient transportation system is absolutely worth the effort.
Thanks for having me on, Steve. It's been great to explore these issues with you.
And thank you to our listeners for joining us for another episode of Auto Intelligence. Whether you're a dealer, manufacturer, or just someone passionate about the future of mobility, we appreciate you being part of our growing community. Remember, we drop new episodes every Tuesday, Thursday, and Saturday, so make sure you're subscribed. The automotive industry is transforming faster than ever, and the sustainability challenges we've discussed today are just one piece of a much larger puzzle. But by understanding these complexities and working together to address them, we can build a transportation system that's not just cleaner, but more equitable and resilient too. This episode was produced by the team at AutoAgentic. Learn more at autoagentic.ai.